So the fundamental counting principle, if two or more situations happen, multiply the total possibilities by each other. They can be the same situation happening more than once, such as rolling a dice and then rolling a dice. Of course, rolling a dice has 6 possible outcomes, and then rolling another dice has 6 possible outcomes. What we're saying here is that we're going to multiply these totals together, which indicates that this would be 6 times 6, and so there's 36 possible results. Now, when we start breaking these up, we may see that some of them look kind of similar, but really all we're concerned about is knowing that there's going to be 36 possible results. We'll also look at a different way to figure these out, but it's possible you could roll a dice, which would have 6 possible outcomes, and then spinning a spinner, depending on how many there are. Let's say that there's 4. If you were to multiply these two together, and again, these 4 we're saying they're different, same with the dice, but that would give you 24 total outcomes from doing these two situations, these two things. Now, generally speaking, we'll use tree diagrams like this. Now, whatever these situations are, this one is only showing 2 possible things that happened first. Maybe that was tossing a coin. Maybe you got heads and tails. Maybe you're choosing from 2 colors, blue or red, something like that. And then you can choose from 3 different options there. Now, notice it's the same 3 for both A and B from the first situation. That's because you're doing the same thing. Maybe this is, I don't know, spinning a spinner with 3 sections in it. So you could spin 1, 2, or 3. But it doesn't matter what happened the first time. Even the second time, no matter what happened there, you'll get a 1, 2, or 3, or a 1, 2, and 3, okay? And then the third situation, again, maybe it's only got 2 options there. Heads or tails, maybe some kind of color, something like that. But again, you notice that it repeats because it has the same options no matter what has occurred before it. Now, what you see here at the end there, this arrow's pointing to the actual outcomes. So this tree, this part of the tree right here going through these branches would produce the results A, 1, and then S. Or maybe this one, if we went from A to 1 to T, it would be A1T. And so it kind of creates what some people even consider a mapping. A tree diagram also works. Sometimes people do it vertically. I have mine set up horizontally. But again, the idea here is, well, how many results are there? And we could count these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 outcomes. Well, how did we get 12? Well, if we use the fundamental counting principle, which is what I would encourage you to do, the first situation had 2 possible outcomes. The second situation had 3 possible outcomes. And then the third situation had 2 possible outcomes. You could have just multiplied these together and then gotten 12 possible outcomes, okay? So right here we counted 12 outcomes. But by using the fundamental counting principle, we kind of took a quick shortcut, and we also found there were going to be 12 outcomes. Now, the tree diagram is nice because it does list all of the outcomes. But again, if all you wanted to know was how many outcomes there are going to be, you could have used the fundamental counting principle. Let's look at this one. You're organizing textbooks on your bookshelf. You have a math textbook, a biology textbook, and a history textbook, and also a writing textbook. That's 4 books. I'll have to make a mental note of that. And then how many different ways can you line the textbooks up in your bookshelf? So there are 4 books. That'll be important to know. And we're going to line them up, so that means we got 4 positions. Now, the thing we need to remember on this one is as we place one book on the shelf, it takes one away from our options. Okay, so in other words, let's look at the shelves here. So I'm going to list these out. Or I guess the order of the books, and we'll say these are positions, okay? So starting as far to the left as I can go, I'd have the first position. Then I would have the second position. Then the third position. And then the last book, since we've already placed all the other 3 books, the last position, 4th position here, is automatically going to just be one final book that remains. Okay. So if I wanted to create a tree diagram from this, so I'll just go in order here. We got, what do we got? Textbook. We got a math textbook, which I will show with just the letter M. Biology will be B, history will be H, and then writing will be a W, okay? But again, I'm going to just start with my math textbook. So if the first position takes the math textbook, then I have three options that are left for my second position. Okay, and those options are given up there. We got biology, we got history, and we have writing. So B for biology, H for history, and W for writing. And from there, I can split these up even further. So biology now, but now since I've got two books on the shelf, I've only got two left over. I can either take history or writing. If I was at history, then I could take maybe biology or the writing one. If the writing one goes on, then you can either have the options of biology or history. Either way, we come to the end here. So on this one right here, I have math, biology, and history, which leaves me with just the option of writing in the fourth position. If I put writing in the third position, then it's possible that history could be there. And then I just go down the line. And again, sometimes this is just kind of common sense when creating the tree. So there in the third position with biology, maybe the writing would be there. If the writing was third, then biology would be fourth. And again, biology being third would make history the fourth position. If history is the third position, biology would have had to be the fourth position. Okay, so I can list my outcomes in order of position, right? So I could say here, the first one, this one, I had math, then biology, then history, and then writing textbooks. And I can do this all the way down the line. So again, the first book was still math, and it was math for all of the outcomes, right? So I'll just put the M there. And then the next one was biology, then writing, and then history. On the next one, again, you can follow through on the branches. Math to history to biology to writing. So math to history to biology to writing. Or math to history to writing to biology for this next one. Or the next one, math to writing to biology to history. Or math to writing to history to biology. And so I could have these books in this order right here, but that was just with math being the first one. And the truth is that I would have to do this for not just math, but then biology, and then history, and then writing as well. Okay, but again, I'm not going to go through and list all these. In fact, I think I will list them all, but I'm not going to go through them. So here they are. So there you go. Well, that's a lot of options. Now, I think somebody could have deduced this from before, but we saw the M with the first position had 1, 2, 3, 4, 5, 6 options, which means each of them will have 6 options, right? So it would have been 6, 12, 18, 24. And so pretty much right off the bat, I think some of you guys could have told from the beginning there would have been 24 results or outcomes. Okay, so, and that answers the question. How many different ways can you line the textbooks up on your bookshelf? 24 ways. Now, besides that, again, the nice thing about the tree diagram is it gives us all of the different combinations that could occur. If you have math first, biology first, history first, or writing first, we can see all the different combinations. All 24 of them in order. But again, we could have used the fundamental counting principle if we wanted to. For example, in the first option, you would have had 4 books to choose from. In the second position, you would have had 3 books to choose from. And again, that's because we had used one of the books up, and then using another book means we would have only had 2 options in the second position, and then finally just 1 position on the third one. As it turns out, if you take 4 times 3 times 2 and then multiply it by 1, you do get the 24 results. And so again, the fundamental counting principle, it didn't ask for the outcomes on this one. I was just showing it so that you know how to use a tree diagram if called upon to do so. But the truth is, in the future, for the rest of the problems, this is all I'm going to be doing right here.